This is not at all connected to any of the part of the any chapter independently. This is actually from chapter magnetic field. Fields due to electric current. Magnetic fields due to electric currents. Moving coil galvanometers. So galvanometers are devices which will not record but sense the flow of current or voltage. So moving coil galvanometer is a device which detects the presence of current flowing. How much current is flowing that it cannot measure, we have to modify it. See, if this is coil and I have to move, then either I should suspend this coil and apply the force this way, equal opposite and rotate, or I fix the coil and apply the force and then it will rotate. So actually speaking, there are two types of moving coil galvanometer. One is called suspended type, other is called pivotted type. In our syllabus, we have got suspended type moving coil galvanometer to be studied. Ammeter, voltmeter are pivotted type, but its working we don't have in the syllabus. Just we have how we can convert a moving coil galvanometer into ammeter or into voltmeter. So moving coil galvanometer. Heading you have written, and this moving coil galvanometer also heading written.
Yeah, sir.
Please write down for 2 marks. This theory is very important, easy to score. Any doubt arises, please ask immediately. There are two types of moving coil galvanometer. In short form, we can write MCG. First, suspended type moving coil galvanometer. Second, pivotted type moving coil galvanometer. Please write this much. Very slow I am going so that it gets by-hearted in the class itself. There are two types of moving coil galvanometer. First, suspended type. Second, pivotted type. If you are done, then please tell. Then I will explain you diagram, construction, working. Yes,
Answer.
okay. Explain construction, working of suspended type moving coil galvanometer with neat diagram. Explain construction, working of moving coil galvanometer with neat diagram. Before I start this topic, few concepts you see separately. Suppose this is one plane mirror and light is incident normally. When light is incident normally, that means incident rays along the normal. In that case, we say angle of incidence is 0. Angle of incidence 0 means angle of reflection is 0. So reflected ray will retrace the same path. Now keeping this incident ray fixed, if we rotate mirror by some angle theta, then clear cut, this normal will also rotate by theta because perpendicular to mirror is called normal. So in this position, I can see that angle of incidence, that means angle made by incident ray with normal, will become I equal to theta. If I is theta, then R will be theta because angle of incidence is equal to angle of reflection. R is theta. So that means from original position, reflected ray rotates by 2 theta. So there is one property, keeping incident ray fixed. If plane mirror is rotated by theta, then reflected ray gets rotated by 2 theta. This we have to keep in mind. Somewhere we are going to use. Keeping incident ray fixed, if plane mirror is rotated by angle theta, then reflected ray gets rotated by 2 theta. Second, what we have to study is, if this is coil wounded on metal frame, when this coil is rotated in magnetic field, then from electromagnetic induction chapter, there is one current called as eddy current is produced. Eddy current means induced current comes automatically in opposite direction. In opposite direction means if this is rotating in clockwise, eddy current will try to oppose the motion and make it, if this is rotating suppose anti-clockwise, eddy current will oppose and make the motion clockwise. Till main current is flowing, eddy current's effect is too small. But as soon as you stop this current, then this opposing current helps to bring the coil back to the original position almost instantly. This is the use. If this is horseshoe magnet, when you see from front, only this line will be visible. When I see from top, then curvature is visible, correct? Yes, sir. So when I say front view, I will draw this. When I say top view, I will draw curvature. Now starting the diagram for moving coil galvanometer. Not very difficult if you understand each and every concept. Because it is moving coil galvanometer, that means we should have coil. It consists of rectangular coil. A, B, C, D. Wounded on rectangular metal frame such as aluminium or copper. It is suspended between the strong magnetic field produced by horseshoe magnet NS. If I see from front, then curvature is not visible. We are able to see this line. So it consists of rectangular coil made up of large number of tons of thin insulated copper wire wounded on rectangular metal frame such as aluminium or copper. It is suspended with the help of phosphor bronze fiber. This fiber has got one constant which we will study in theory called as torsional constant value, very small. With that value very small, What is that value? I will explain later so that you get the idea why we are using this phosphor bronze fiber. Again, I am repeating. It consists of rectangular metal. It consists of a coil made up of copper mounted on rectangular metal frame such as aluminium or copper. It is suspended with the help of phosphor bronze fiber between the strong magnetic field produced by horseshoe magnet Ns. The deflection produced in the coil is measured with the help of mirror and lamp scale arrangement. Mirror and lamp scale arrangement. Lamp scale arrangement is not shown in the figure. Now what is lamp scale arrangement? If this is mirror, here there is lamp which is making light incident. If we don't rotate the mirror, it will get reflected back. Wherever it is reflecting, we'll mark that as 0 because there is no change in the position of mirror. Then we rotate the mirror by 10 degree, 20 degree, 30 degree, 40 degree, 50 degree, keeping incident ray fixed. So our reflected ray will move by 10 रहेगा तो 20, 20 होगा तो 40. अभी समझा आपको? Keeping incident ray fixed. If mirror is rotated by theta, reflected ray will rotate by 2 theta. So we rotate the mirror by 10. Reflected ray will move by 20, but while writing will write 10. So advantage ये दूर spread हो गया. So there won't be much error. Easily we can note the reading. That is mirror and lamp scale arrangement, not to be studied for this diagram or this theory. But you should know what is mirror and lamp scale arrangement. It consists of rectangular coil made up of large number of tons of thin insulated copper wire pounded on rectangular metal frame such as aluminium or copper. It is suspended with the help of phosphor bronze fiber between strong magnetic field produced by horseshoe magnet Ns. Deflection produced in the coil is measured with the help of mirror lamp scale arrangement. A soft iron core I is mounted in such a way that coil can rotate freely. That means, suppose I put one iron between the coil के बीच में gap है, because coil is not solid, खाली boundary है ना, coil उसका आगे पीछे easily move कर सकता है. So ये iron core will make the field strong because iron gets attracted by the magnetic field. So it will make the field strong. Because it is generally kept at center, ये field पूरा center से pass होएगा. So it will become radial and strong magnetic field. Current enters through the fiber and leaves through helical spring which supports the spring coil from lower end. So इधर से current enter होएगा, इधर से current बाहर आएगा. Front view is as shown in figure A. Now let us see top view what it will look like. When I see from top, I can see three things. First, that iron core which is cylinder. तो ऊपर से मुझे उसका circle दिखेगा, not rectangle. See, when I see this cylindrical part from front, so I am seeing this. But when I see from top, तो मुझे circle दिखेगा ना? So I will be able to see circle. That means that cylinder I का circular part. और ये magnet का curvature. इसके बीच में coil. When I see from top, so I will be able to see this thickness of the coil. So keeping this in mind, or by imagining proper posture, I can draw now top view of the moving coil galvanometer. Front view is as shown in figure A. This is top view. So from top, you will be able to see north pole ka curvature and south pole ka curvature, not the straight line. And this iron core iron core. And here that coil ka thickness from the top. Field will be from north pole to south pole passing through center. So it is called radial. Field we cannot see, I have just drawn, it is imaginary. So front view and top view of moving coil galvanometer is as shown. Have you followed the diagram?
Yes, sir.
Please copy the diagram properly. Kamya? Hello, Kamya?
Yes, sir.
That formula which I had given, was it useful in the exam?
Sir, exam is on Thursday.
Okay, that
But
is
yes, it was helpful to revise.
okay. Once you complete the diagram, tell, then I will give the description of this.
Done, sir.
Okay, can I clear the diagram?
Yes, sir.
Okay. So this diagram we will write as a description in construction. If they ask only diagram, then no need to write construction. It consists of rectangular coil A, B, C, D wounded on. It consists of rectangular coil A, B, C, D wounded on rectangular metal frame such as aluminium and copper. It is suspended with the help of phosphor, bronze fiber between strong magnetic field produced by horseshoe magnet NS. A soft iron core I is mounted in such a way that coil can rotate freely. Copy this much. Or once you complete, then tell, because one more paragraph is pending.
Done, sir.
Okay. Everybody has completed till last line?
No, sir. No, sir.
Again, you have completed?
No, sir. I'm writing last time. Done, sir.
It can rotate freely. Iron ore helps to make field strong and ready. The deflection produced in the coil is measured by mirror and lamp scale arrangement. Now this arrangement we have not shown in the diagram. Coil is measured with the help of mirror and lamp scale arrangement. The current enters from the fiber and comes out through helical spring. The front view and top Q are as shown in figure A and B respectively. Right.
Answer.
Everybody is done? Yes, everybody is done?
Yes, sir.
Okay, again.
Yes, sir.
Next, right. Theory or principle of working of moving coil galvanometer. Theory or principle of working of moving coil galvanometer, or they can say derive expression for current flowing through moving coil galvanometer. Consider a rectangular coil P, Q, R, S having n number of turns, area of cross section A, to be placed in uniform radial magnetic field B bar. When current I is passed through the coil, then vertical side PQ will have current in downward direction, RS will have in upward direction. Clear now? Why? ये कॉइल ऐसा आएगा, ऐसे 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 पीछे ऐसा वाइंड अप रहता है. पीछे पीछे, इधर से करंट ऐसा आएगा, इधर से ऐसा जाएगा. Is it correct? Which I have shown diagram. Hello. Direction of current followed.
हाँ सर.
Consider rectangular coil PQRS made up of n number of turns, area of cross section A to be placed in uniform radial magnetic field of induction P bar. Let L and P be the length and breadth of the coil. When current I is passed through the coil, vertical side PQ and RS will experience force. Force acting on a conductor carrying current I having length L when placed in field is ILB sine theta. Because this is I and this is field, angle is 90, force will become ILB. Same way on this vertical side, current is I, length is L, field is 90 degree. So this will also experience same ILB wala force. Direction of force is given by Fleming's left hand rule. Imagine three fingers of left hand, index finger, middle finger and thumb to be outstretched mutually perpendicular to each other. Index finger represents magnetic field, middle finger represents current, then thumb represents force. So if I look at PQ wala conductor, from my left hand I am opening the palm, closing the last two index little finger and forefinger. I am opening the three fingers mutually perpendicular. Always start with field. So index finger is field. My index finger I am pointing towards right. Middle finger downward. Force I can see outward. Just see with your hand. Whatever I am explaining, I am doing with my hand. So I am just taking index finger on the right side, current ka middle finger downward, so I can see my thumb is coming out. You all just analyze with your own fingers what you are getting. Tell me, is it coming out?
हाँ.
Okay, this will come outward. For SR side, B is on the right, move the middle finger upward, my thumb is coming inward. For you also, I think it is same. This F is coming outward. This F is going inward. Are you getting same? Amay, you got same? Yes, Amay, you are getting the direction properly?
Yes, sir.
Index finger to the right, current wala middle finger ऊपर.
Middle finger.
So thumb अंदर inward जा रहा है ना, left hand वाला, right hand से मत देखना. Left hand.
हाँ सर, लेफ्ट हैंड ही देख रहा हूँ.
मिल गया बराबर inward?
Yes, sir.
Okay. So you got two force. One is acting on PQ, other is acting on RS. Are they equal in magnitude? That is ILB. दोनों का magnitude same है ना, ILB.
Yes.
But direction, one is outward, other is inward.
Inward.
Any special name for equal and opposite force? Equal opposite force को कुछ बोलते हैं क्या हम लोग? It is called couple. So these equal and opposite forces will form couple, which will produce deflecting torque. Torque मतलब rotate करेगा इसको. चलो पहले डायग्राम बनाओ इतना. Draw diagram, then I'm explaining further. After drawing the diagram, please write this what I have written. Yes, completed.
Yes, sir.
Okay, everybody is done.
Yes, sir.
Again,
Yes, sir.
so we got equal and opposite force F equal to ILB acting outward and inward. These equal and opposite forces forms couple and produces deflecting torque. That means it will deflect the torque these equal and opposite forces forms couple and produces deflecting torque given by tau d. Tau means torque, d means deflecting. It is equals to any one force into perpendicular distance between two forces. So deflecting torque is force ILB, perpendicular distance between this outward, inward force is width, which is B. So it is ILB is torque acting, which is deflecting the coil from its rest position. But length into breadth means area A. So we can say deflecting torque is IAB. For n turns of coil, deflecting torque will become NIAB. Let this be equation. Copy to this. Is completed till deflecting torque NIAB. When coil gets deflected, then suspension fiber gets twisted, because when coil will get deflect, ऊपर वाला wire twist होगा, gets twisted and produces restoring torque given by producing restoring torque. इधर तक लिखो, फिर आगे लिखता हूं. When coil gets deflected, then suspension fiber gets twisted and produces restoring torque.
Done, sir.
When coil gets deflected, then fiber gets twisted, produces restoring torque, which is directly proportional to angle of deflection. Means जितना deflection होएगा उतना twisting होएगा. Produces restoring torque, which is directly proportional to angle of deflection theta. Therefore, restoring torque comma tau r proportional to theta. So this tau r equals to k theta, where k is a constant called as torsional constant. Sometimes it is also called fiber constant. Sometimes restoring torque or unit angular displacement. Completed? Hello, completed till this?
Yeah, sir.
Everybody has done equation 2 तक?
Yes, sir.
हाँ sir.
At equilibrium. Equilibrium means net force 0, net torque 0. So at equilibrium, deflecting torque will balance restoring torque. Deflecting torque we got NIAB and restoring torque is K theta. So I is K upon NAB theta. Since K and AB are constants, therefore we can say I equals to constant into theta. That means I is proportional to theta. So current flowing is K upon NAB theta. That means I is proportional to deflection theta. This is theory or principle of working of moving coil galvanometer. Completed this.
Done, sir.
Okay. Can I clear this top heading? Full part?
I'm not done, sir. I'm still writing.
Right.
Done, sir.
So today I stop here. Please revise and come in the next lecture, that is tomorrow, same time. Sorry, 8:30